Okay, we're down to our last carboxylic acid derivative. In this video, we're going to talk about nitriles. And for the nitriles, we're going to talk about a number of preparations and reactions. I'm not going to ask you to know the mechanisms for any of these reactions. Okay, first let's talk about preparation of nitriles. And the first one we've already seen. So we've seen that we can make nitriles by starting with an alkyl halide and doing an SN2 reaction. So the reagent that we would use is sodium cyanide in this case, where the sodium is just a counterion. What we're really interested in is the cyanide ion. It'll act as a nucleophile and replace the halogen. Another way to make nitriles is through dehydration of a primary amide. We can use a variety of reagents for that. SOCl2 is a very common one. The book shows the mechanism if you're interested. I'm not going to ask you to know that. I would just add to your reaction list the dehydration of primary amides with SOCl2 to give us the nitrile. Okay, this is a review of another reaction that we've seen a couple times. We saw it both last chapter and then at the beginning of this chapter as ways to make carboxylic acids. If we start with the nitrile and then heat it under acidic conditions, it's first hydrolyzed to the primary amide and then it's hydrolyzed to the carboxylic acid. And then just like the esters and the amides, the nitriles can be hydrolyzed under acidic conditions as we just saw. It can also be hydrolyzed under basic conditions to give us the carboxylic acid. And just like the reactions with the esters and the amides, because we're doing this under basic conditions, it's going to result in the formation of the carboxylate ion. And so I need an acid workup to protonate that carboxylate ion and give us the final carboxylic acid. So one new reaction, nitriles can be reacted with Grignard reagents and they'll actually stop at the ketone. So after the nitrile reacts with the Grignard reagent, and that's very similar to the reactions that we've seen with the Grignard reagents before, essentially we just have the nucleophilic addition reactions. When we then protonate this with excess acid, that's going to give us the imine. And we talked about the hydrolysis of imines last chapter, and so the imine will be hydrolyzed under those acidic conditions to give us the final ketone product. And so if you want a refresher on that mechanism, go back to the last chapter and look at the hydrolysis of imines. Okay, and as we've seen with these other carboxylic acid derivatives, we can also react the nitriles and reduce them with lithium aluminum hydride. And just like the amides, the nitriles are converted to primary amines as a result of this reduction. So the acid halides, the acid anhydrides, and the esters are all converted into primary alcohols. The amides and the nitriles are converted to primary amines.